All right, sum and difference identities. Fun fact, on the island of Yakushima, these monkeys ride deer for transportation, and in return, they groom the deer and share food with them. That is like the cutest thing I've ever heard. Another fun fact, I am a quarter Japanese. My grandma is full Japanese, and my great-grandparents immigrated over here from Japan. Kind of cool. I love the Japanese culture, and my goal is to go to Japan one day. I'm definitely going to once the pandemic is over. Okay, anyways, so sum and difference of angles. So there's these three equations here. You can either pause the video, definitely pause the video and write these down. I am so sorry, please forgive me. You have to memorize these. Okay, so sine of A plus B is the same as sine of A times cosine of B plus cosine of A times sine of B. You don't have to memorize these. That was a lie. I'm giving you an equation sheet, so that will help, but you do need to write these down. Okay. So we need to find the exact value of each trig function. So sine of 105. Like if you think about the unit circle, 105 is not on the unit circle, right? So we need to, how do we find that? Like if I wanted the exact value, I want the square root value of this, what do? So, oh no, don't forget the unit circle. So if you need it, grab your unit circle so we can have it, okay? So 105, well, that's the same thing as 45 plus 60. Okay, so if I do sine of 45 plus 60, that's the same as like sine of A plus B. A would just be 45, B would be 60. So then I'm going to plug this stuff in. So I have sine of 45 times cosine of 60 plus cosine of 45 times sine of 60. Which I know that sine is the y values. I'll write this real quick. So sine is the y values. Sine is the y values, if you remember from the unit circle, and cosine is the x values. Okay, so then sine of 45, well, I can just look at my unit circle and figure out what that is. That's square root of 2 over 2. Cosine of 60 is 1/2. Cosine of 45 is square root of 2 over 2, and sine of 60 is square root of 3 over 2. So then simplify this. That's going to be square root of 2 over 4 plus square root of 2 over 6. Square root of 2 over 4 plus square root of 6 over 4, which I could make that one fraction. That's square root of 2 plus the square root of 6 over 4. So sine of 105 is the same as square root of 2 plus square root of 6 over 4. Let's do another. So if I have cosine of 165, well, that's the same as 45 plus 120. So then I'm using the cosine formula here. So that's going to be cosine of 45 times cosine of 120 minus sine of 45 times sine of 120. And there's a cool little video if you have time and you want to watch it. I put it underneath this video that kind of goes over like how you can prove that these work. And it's kind of cool. I've never even thought of it that way. But anyway, so the cosine of 45 is square root of 2 over 2. Cosine of 120 is negative 1/2. Sine of 45 is square root of 2 over 2, and sine of 120 is square root of 3 over 2. So that's negative square root of 2 over 4 minus square root of 6 over 4. So that's going to be negative square root of 2 minus the square root of 6 over 4 is what cosine of 165 equals. Okay, so cosine of 19 pi over 12. Well, I don't like working in radians. I'm going to convert it to degrees. So that's the same as cosine of 285, which is the same as cosine is 315 minus 30. And granted, there are a lot of different ways to get 285. Like you could do like 225 plus 60. Or you could do 330 minus 45. Like there's lots of ways you can get this. So there's lots of ways to go about it, but you'll always end up at the same thing, okay? So then I'm going to use this formula, the cosine A minus B. So that's going to be cosine of 315 times cosine of 30 plus sine of 315 times sine of 30, which cosine of 315 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Sine of 315 is negative square root of 2 over 2, and sine of 30 is 1/2. So that's going to be square root of 6 over 4 minus square root of 2 over 4 which is square root of 6 minus square root of 2 over 4. Okay, let's do another. So this one, sine of negative 5 pi over 12, convert it to degrees, is negative 75. I also don't want to work with a negative, so I'm just going to add 360 to that. And that's the same as sine of 285. So then I'm going to just do 330 minus 45 for this one. And I'm going to use the sine of A minus B. So that's going to be sine of 330 times cosine of 45 minus cosine of 330 times sine of 45, which is negative 1/2 times square root of 2 over 2 minus square root of 3 over 2 times square root of 2 over 2, which is negative square root of 2 over 4 minus square root of 6 over 4, which is negative square root of 2 minus the square root of 6 over 4. Okay? Tangent. Okay, tangent is so fun. Tangent of 13 pi over 12. I'm going to convert it to degrees. So tangent of 195. Well, that's the same as 45 plus 150. So I'm going to use this. So I have tangent of 45 plus tangent of 150 over 1 minus tangent of 45 times tangent of 150. Well, the tangent of 45, remember, that's the y divided by the x. So that just equals 1. That one's easy. Tangent of 150, that's going to be 1/2 divided by negative square root of 3 over 2, which is 1 over this negative square root of 3 over 2, which is negative square root of 3 over 3. Okay, so let's plug that in. So I have 1 plus negative square root of 3 over 3, and 1 minus 1 times the negative square root of 3 over 3. Okay, well, now let's simplify this down a little bit. That's going to be 3 over 3. I just changed the 1 to 3 over 3. And then plus and negative is just minus. And then again, I changed the 1 to 3 over 3. And 1 times that is just that, but a negative times a negative is a positive. Okay. Now I can make this one fraction. So I have 3 minus the square root of 3 over 3, and 3 plus the square root of 3 over 3. Now these 3's can just cancel out right here. So I have 3 minus the square root of 3 over 3 plus the square root of 3. And we have to rationalize it. So we're just working a lot with square roots right now. So I'm going to multiply by 3 minus the square root of 3 to top and bottom. Now on top, it helps to just kind of use a box right here. I mean, you could do it by distributing, but this is going to be 9, negative 3 square roots of 3, negative 3 square roots of 3, and 3. So that's 12 minus 6 square roots of 3. So that's what the top is. And on the bottom, I have 3 plus the square root of 3, 3 minus the square root of 3. So this is 9, 3 square roots of 3, negative 3 square roots of 3, and negative 3. So these cancel, and I'm just left with 6 on the bottom. Okay, so that is 12 minus 6 square roots of 3 over 6, which is 2 minus square root of 3. Okay, it's a lot of algebra. It's just a lot of simplifying. Let's do one more. So negative 7 pi over 12. Well, that's the same as tangent of negative 105. Again, I don't want to work with a negative, so I'm just going to add 360. That's tangent of 255, which is the same as 300 minus 45. So that's this right here. So I'm going to do tangent of 300 minus tangent of 45, and then 1 over tangent of 300 times tangent of 45, which tangent of 300, or tangent of 45 we've already figured out is 1. Tangent of 300 is negative 3 square root of 3 over 2 over 1 over 2, which is negative square root of 3 over 1, which is negative square root of 3. So this is going to be negative square root of 3 minus 1 over 1 plus negative square root of 3 times 1, which that's negative square root of 3 minus 1, and then 1 minus the square root of 3. So I'm going to rationalize, multiply both sides by 1 plus the square root of 3. Let's just use boxes again. So then here we have negative square root of 3 minus 1, 1 plus the square root of 3. That's negative square root of 3, negative 1, negative 3, and negative square root of 3. So that's negative 4 minus 2 square roots of 3. do this other one. So we have 1 minus the square root of 3, 1 plus the square root of 3. So that's 1, negative square root of 3, positive square root of 3, and negative 3. So that's over negative 2. Okay. So then here, that's going to be negative 4 minus 2 square roots of 3 over negative 2, which is 2 plus the square root of 3. Cool? Okay, so we want to condense this into a single trig expression and then find the exact value. So cosine, cosine, minus sine, sine. So let's figure out which one that is. That's got to be the cosine of a plus b. So that's cosine of 300 plus 15, which is cosine of 315. Then if I look at my unit circle, 315, the x value there is square root of 2 over 2. Not too bad. Let's do the tangent. So tangent of 5 pi minus 18 minus tangent of pi over 36, blah, blah, blah. That is going to be this right here. So that's going to be tangent of 5 pi over 18 minus pi over 36. I'm just going to change those to degrees. So that's 50 minus 40, or minus 5, which is tangent of 45. Now, if I look at 45, we figured this out a couple times. That just equals 1. Okay. So we want to simplify each expression here. So if we have cosine 2x, cosine 4x, plus sine 2x, sine 4x, well, that is going to be this one. So that's going to be cosine of 2x minus 4x, which is cosine of negative 2x. But if you remember our even odd functions from last time, the cosine of a negative theta is just the same as cosine of theta. So that's the same as cosine of 2x. Okay, so if we have tangent of 4 theta plus tangent of theta, and then 1 over tangent of 4 theta and tangent of theta, that's tangent of a plus b. So that's tangent of 4 theta plus theta, which is tangent of 5 theta. Okay, let's do this one. So sine of pi halves times cosine of alpha minus cosine of pi halves times sine of alpha. That is going to be sine of a minus b. So that's going to be sine of pi halves minus alpha, which sine of pi halves minus an angle is just the same as cosine of that angle. Let's do this last one. So tangent of y minus tangent of pi halves, 1 plus tangent of y times tangent of pi halves. That's this one. So that's going to be tangent of y minus pi halves, which is almost what we want down here. But we need to manipulate this a little bit. So I'm just going to factor out a negative here. If I factor out a negative, I get negative pi halves minus y. Because here, I'll go through the work right here. So if I divide both these by negative, we get tangent of negative y plus pi halves, which is really the same thing as tangent. And that negative has to stay on the outside of negative pi halves minus y. Okay, because I divided by this negative 1, so this negative 1 is still on the inside here. Which I know down here it tells me that tangent of a negative is the same as negative tangent of whatever that is. So that's going to be negative tangent of pi halves minus y, which pi halves minus an angle is just the cotangent of that angle. Okay? Okay, bye.